Hey everybody, how's it going? I am Kuit the Geek, and this is Professional KiCad. How do you go about creating libraries and schematic symbols? Let's get into that. So first of all, I do want to apologize for the sound of my voice. I am coming off of a cold, so that has changed it a little bit. But I'm trying to get through that, so bear with me a little bit. Also, I want to thank my first patron from Patreon. That would be Tom Van Loon, and your support is greatly appreciated. Thank you very much. For those of you that are interested, you can check out my Patreon and the link in the description below. But for right now, let's go ahead and just jump right into this. So here we are at the main interface for KiCad. So today we're talking about libraries and schematic symbols. So instead of going through and opening up a schema, or e-schema, we're going to go through and open the symbol editor. It'll take a second here to load up all the libraries, and then it'll pop up and be ready to go. So the first thing we've got to do is we're going to create our first library. So we're going to come up here and we're going to click on File and New Library. And I've mentioned this before, but I do like to keep a local.lib. That way my project is portable and it's able to handle version control a little bit better. All of the parts are saved to a library instead of counting on the cache library. I've had issues with that in the past. I don't know if they've changed that with how they've been working on things, but this is basically the way I've done it for a little while, and this way I'm managing my own library and doing what I want with it specifically. And you'll see some of the reasons why in just a little bit, but let's go ahead and get into this. First of all, we're going to create a new name for the local library. We're just going to call it local.lib. And we're going to place this in the root with our project. So everything that comes along with that, we're going to have it all together there. Go ahead and hit save. And this pop-up is going to ask if we want to add this to the library table as a global or a project library. We're going to turn this into a project library because we don't want this to be seen by all of our other projects when we create them. We want this to be project specific so that the only things that are in here are for the project we're working on. So we're going to hit OK, and that's going to create our library right down here. Now the next thing we want to do is we're going to go ahead and start adding some parts to this. There are a few things that I know I will always use. For example, resistors, capacitors, probably LEDs, and some diodes. So those are found in this device library that is included with KiCad. First of all, you can see there's this C, that's just the general capacitors. If you right click and hit save as, or save a copy as, it'll bring you up an option here, and you can just scroll down, find the local library we just created, and hit save. Now you can see here our local library includes a C. So this is our capacitor. Let's go ahead and do the same thing for a few other parts, such as resistors and some of the power things we're going to want. I like the RUS symbol for the resistors myself. There's others that you can use, and this is kind of all to personal preference. But I'm going to go ahead and save a copy of this, and I'm going to modify it down so that it's just R, and find our local and save. Now if I come in here to R, everything should be taken care of and it should be ready to go. At this point you can see that the libraries have an asterisk next to it. It means that it is not saved, so if you go ahead and just click on that, it will go ahead and take care of that and get it saved for you. You want to do this frequently so you don't lose work. Another thing we want is some power symbols. So let's go ahead and find our power. And we're going to grab a few things like our 3.3 volts. Let's go ahead and save that. We'll want probably 5 volt for this project as well. And we're going to want to grab a ground reference. So I prefer this symbol. It's just one that I've used for a long time. There's the standard ground as well that you can use with the triangle, as well as just a few other things. But I prefer ground ref. And so we'll just go ahead and copy this one, modify it down just to ground, find our local library. And then one thing to note with this is you can see this line here where it does still reference it as ground ref, but it calls it ground here. So if you come into the pin, hit E to edit, and come to pin 1, then we can come through and change the pin name so that it is just ground. And there we go. So we'll go ahead and save this again. Now let's go through a few things that I like to do for my individual parts. So let's take a look at the resistor, for example. So this is just a basic resistor. There's nothing really added to it. Now I always like to use the 0603s for most of my work, unless there's a reason to jump up to a different size resistor. So what I'm going to do is I'm going to come up to this button up here. This is the fields for the symbol, and it's just basically the symbol properties. And so we're going to go ahead and we're going to add in 4 new fields, and we're going to click the boxes so they're not showing. The first box we're going to call MFG PN. That's our manufacturing part number. We're going to grab this directly from DigiKey or Mouser or wherever we get our parts from. Once we do actually hit that, we can put in a little tilde over here to act as a placeholder. The next thing we want to do is do a part link, and again put in another tilde since we don't actually have the part yet, but we want to be able to store all these fields to use them later. So this next field is called config. This is for configuration. Generally I will mark this as fit. If I'm putting a part onto my schematic but I don't necessarily want it to be there, I will mark it as do not fit. Or there's other cases where you can actually use configurations and do some different things, like for example you might use some parts in one configuration, so you call that config 1 and you only populate those parts, and then you might have a second configuration that you'll populate a different set of parts with, and so you can label that in this config field as well. The last field I use is description, and this is basically just when I go through and grab the descriptor from the website such as DigiKey or Mouser. So I can know what the value is, what the tolerance is, the package size. With capacitors you might want to know your temperature coefficients as well. And that way if you ever have to send this off to a fabrication house or an assembly house to be able to go through and they can find new parts based off of what you've spec'd, and this will all be listed out in the bill of materials when we get to that point. We do also want to grab the data sheet when we're over at our part, and right now we're actually going to go through and assign a footprint. So like I said, I like to use the 0603, so if you click on the little library button there, it'll pop up our library selector. You can scroll down here to resistor SMD, and you can either grab the 0603 or the 0603 hand soldering. The difference is just the pads are a little bit bigger, but I generally just use the 0603s. I don't have trouble soldering to them, so I just grab that one, since a lot of the work that I do, especially professionally, eventually will go to a pick and place machine with a solder stencil, so that really won't be that big of a deal. So I'm just going to go ahead and select this one. You can double click on it and that will fill that footprint, and we'll hit OK, and that will post a lot of these things into here. You can hit M to grab it and move it, R to rotate, and you can place these up so that they're out of the way. And you can see that it's kind of held those other fields, but it keeps them hidden. We're going to grab our fit, we're going to put that right there. As we populate those other fields, this whole thing will grow and you'll be able to see that in a minute. Another thing to take note of within this library is you can edit the spice model if you want to do simulation on these parts as well, and you can go through and set that so that it is accurate and representative of your parts. So now that we have our resistor field set up, let's go ahead and save that. And let's start by creating a new part that is not in the default libraries. So we're going to go ahead and take a look at this memory module. This is just an EEPROM. And we're going to go through and create this real quick just because it's going to be a fairly simple part. Not because I intend on using it, because as you can see up here, this is actually a non-stock part. So I wouldn't want to buy this one particularly, but this will illustrate what it is we're talking about. So first of all, we're going to come over here and you can right click, or you can come up to add a new symbol, but we're just going to tell it new symbol right here. We want to know the symbol name, so we're going to use the name of the part, which is AT24CS16. And we're going to refer to this with a U designator, and we're not going to do multiple packages or multiple units on this package. You can do that, especially when you're running with logic chips and things like that. You might want to grab, do 4 or 5 units so you can separate the power out from each individual gate, but we're not going to worry about that right yet. And there's some different options here that we are currently going to just leave as defaults. So let's hit OK. And you can see this will just give us our reference designator and our pin number. So we go ahead and use M again to move, kind of get them out of the way here. And let's pull up this datasheet. So the first thing we want to look for is going to be our pin descriptions. So we're going to find our pins right here. You can see this has 3 pins that are not connected internally, 1 that's ground, 1 for SDA. This is the data line of the I2C communication protocol, and SCL, which is the clock line, WP, which is write protect, and our VCC, which is our power supply. So let's go ahead, and you can come up here and just click on this button to add new pins and add in a new pin. It'll open up the pin dialog, and you can say NC pin number 1, change this to not connected, and the orientation on that you can modify however you need to. This is going to be right orientation, and we can drop that in there. Or we can come up here to this pin table button, click on that. You're going to see all the information we just added in for that part. Now we can go through and add on 7 more pins. Let's get these named appropriately for pin numbers. And now we can take here and call this not connected, ground, SDA, SCL, WP, and VCC. We can change our electrical types through this. Now our ground and our VCC are both going to be labeled as power inputs. I know it feels a little weird because you're expecting power to go through this chip, but this is basically saying this is how we're providing power to this chip. So you are actually inputting the ground reference into this chip as well. Power output will come from things such as voltage regulators, where you are applying a voltage on an input pin and getting a certain voltage out. And we'll talk about that later in an advanced series when we talk about power supply and switching power supply design. So for right now, we're going to call this a power input. SDA, this is our data line, so this is actually going to be bidirectional. And our SCL, which is a clock line, is just an input. Write protect is also an input, and come to power input for VCC. Hit OK, and all of our pins are going to be dropped right here. So we'll go ahead and start moving these around a little bit. Don't believe I've mentioned this, but you can scroll on the scroll wheel to zoom in and out. Now something seems a little different with this pin, so let's go ahead and take a look at that. So this is a visible pin. For some reason we don't have our line coming off. Okay, well let's go ahead and check those boxes just to make sure that everything is the same. I think the only difference here is going to be our pin length, probably. The text size and things could also cause a problem, but let's just go ahead and grab the pin length for right now. Yep, that doesn't have a pin length, so there's your problem. There we go. So we've tweaked those parameters. Now we have a matching pin. Go ahead and save our work again so we're not losing anything. Now, there's a couple of ways to go through and lay these things out. The first thing that I'm going to show is just laying it out as the part itself is laid out. So that's going to be pins 1 through 4, and then pins 5 through 8, with those being inverted. So we can highlight these pins, move them around, and we're going to want to center this around this origin point, because that is actually going to be the origin of the part. Now, let's grab these. We can rotate that by clicking R. I generally like to make sure that the pins are the same distance from the center. So if you hold the mouse over that center pin, you could look down in this area over here to see the dx, the dy, and the distance, as well as the relative position points. And so this is going to be 8.9, and this is 11.43. So these we can move over just a little bit more, probably about to there. Check again, that's 8.9. Okay. So now we're going to want to go ahead and wrap a box around these. This is kind of personal preference to how you want the part to look. So you can just grab the box and wrap it around like that, and we can right click and edit the rectangle options and fill with a background color. And this will give it a yellow background so that we know this is actually an integrated circuit, not just a passive or discrete component. Now we'll come back here and grab our reference designators and things and scoot those down a little closer, and that is our chip. Now there's another way that you can do this, which isn't based off of the physical layout of the part, but based off of what would make more sense. So let's go ahead and look at that real quick. So we're going to go ahead and get rid of our body. And now what we want to do is we're going to come into our non-connected pins, we're going to edit them and make them invisible. So those pins will no longer show up. We can grab them and rotate them, move them wherever we want to. And now we also want to grab our power pins. So we'll put VCC on top here. Let's grab our write protect and bring that down. And we'll grab our SCL and our SDA. Move our write protect here. And these pins we can just reverse around and put somewhere they're not really critical because they're not actually there. In fact, what I would probably do is just stack them right on top of each other so they don't get in the way of anything. And now we can come up and redo our body. And this time you can see it's actually a little bit shorter. We can come in here and grab with a G and extend that down so that this part looks like it's more symmetrical, and move our pins with M, right click, or we can even hover over and hit E, and that'll bring up that drawing option as well, and fill background. And this can give us a different way to look at our part because now it's more logically laid out. We can power our chip through these pins, bring in our comm lines over here, and then have our write protect and just ignore those. So that's two different ways that you can look at the actual layout. Now before I would call this done, I'm going to come up here to our symbols again, add in those 4 fields. And now that we have all of that in, we're going to bring up DigiKey again. Now this is where you're going to find all of this information. So we have our datasheet already linked here, so we're going to go ahead and copy our link location and place this in here. We're going to copy our manufacturing part number, just Control V that in, come up here and we're going to copy our address for our part. Let's grab our description so that we know this is an IC EEPROM 16K using I2C running at a 1 MHz clock, or capable of a 1 MHz clock, and in the SOIC 8 package. Now the last thing we want to do is actually find that SOIC 8 under our footprints. And this is going to be under a package SO. Come down to SOIC 8. All of these that say EP actually have a pad that is intended for an EPAD, basically. They'll usually be referenced to ground. The part that we do want, though, that is going to match our data sheet. Let's go ahead and look at that real quick. So here's our data sheet. This is going to have our dimensions for E, for E1, for D, and for little e, which is the pitch between our pins. And we know this is a SOA gate. Let me scoot this over so we can look at both of these side by side. We know this is a SOA gate. Now if we look into our dimensions, we'll look at E1 first. And this is saying it's going to be between 3.81 and 3.99. That's where our 3.9 comes in here. And then our D is going to be 4.8 to 5.05. That's where our 4.9 comes in. And then our little e, which is down here, is 1.27. Also, keep in mind this is all in millimeters. This is metric. And this is our pitch, which is 1.27 millimeters. So this is the correct part. You'll always want to verify that. If you are making the footprint yourself, which we'll cover in a later video, you'll also want to have that checked. If you have somebody that can go through dimensions for you to just give you a sanity check and make sure that everything is correct, then you will save yourself a lot of heartache when you actually order these parts and something comes in and holes aren't in the right places or pads are covered by solder mask or something like that. You'll just have a check to make sure that everything is the way that it's supposed to be. So now we have all of our fields populated. We can use this same description actually and just go ahead and grab that and put it down with our description here and hit OK, and we'll go ahead and hit save. You can see this dropped all of these fields over top of each other. We'll use that move command one more time and we're going to move all of these fields. These are all hidden, so you're not going to see them. They're not going to show up above the part, but if you want to, you can actually make certain fields visible. This can come in handy, especially if you are putting in a part that is a do not pop or a do not fit. You can just come into that config field, hit, or just type in do not, pop over here and turn on that show, and now it'll show up purple saying do not fit, so you know that that's what the configuration is for that part. I'm going to go ahead and undo that. And that is it. That's our custom part done. So that's how you're going to go about creating custom symbols you need to use for your library, and then everything else that you can find, I would recommend looking through the KiCad repository first for these parts that they have already got and see if they've got the same part that you're looking for. If not, this is your fallback. Go through and create it in whichever fashion you like to. I jump between doing the physical pin layout versus a logical layout, and it really just depends on what makes the most sense for it. So, save that one more time. Everything looks good here. And I think that's going to just about do it for us. Okay, so that's it. That's how you go through and create your own symbol libraries and your own symbols in KiCad. Now, this is how I do it specifically. I do this, again, for several reasons, because this helps me within my professional setting, where keeping a local library, I can maintain that better. It will work with my version control. I use Git for versioning, and it helps it to be portable so that I can have my coworkers pull down my projects and they have everything already self-contained. So they're not losing parts, they're not losing things that I've already created. There's no issues with the caching libraries possibly glitching or causing some problems and trying to rescue. It's just already self-contained and done. And this is how I go through and I create all my symbols all the time. I've done this a lot. If you have any questions, be sure to let me know in the comments below. I'm happy to help out with any of your projects that you're working on or anything. Just let me know that. In the next video for this series, we're going to start talking about how to actually go through and maintain some of your schematic. And we're going to start jumping in some later videos about how to run a hierarchy, how to go through and create your footprints, how to create your bill of materials, how to create your PCB, generate your Gerber files, generate 3D models, all the stuff that you need to know to get your project off the ground and looking professional. But as far as it goes, that's pretty much it for right now. Be sure to like, comment, and subscribe. As I mentioned before, thank you again to Tom Van Loon for supporting me on Patreon. If you're interested in supporting me on Patreon, check out the link in the description below. But that's patreon.com/Kuit the Geek. Check me out on Twitter at Kuit. That's usually where I send out my community announcements and stuff. If there's a way that would work best for you, let me know. Also, be sure to check out my website, which is kuitthegeek.ddns.net. And as always, thanks for watching.